And welcome to Coding Wizards. My name is Akash Sharma. I have 7 years of experience in Android and Flutter development. Today we will start with the classes and inheritance. This is the last lecture in the Flutter Dart series where we covered the Dart basics. After this we will start with the Flutter, widgets, state management and all. So in this lecture we will see all the examples of classes, inheritance, how they can be inherited and how we can make use of these things. So we will start with the abstract class. We have abstract class examples, base class examples, all types of classes. Then we have final class examples, and so we will start with the simple normal class. Like if we write like a b c, this is a normal class. So after this we have like base keyword. So these are modifiers like base, final, abstract. Then we have interface class, then have abstract interface class, we have sealed class, we have mixin and mixin class. So all these things are modifiers. So everything like this is a normal class. If we add base in like as a prefix, so it will be like it will behave differently than the normal class. So we will see what are these things, how we can use modifiers, and what are the use cases where we can use each of these. So first we will start with the base class. So it is a class which can be instantiated, like we can create a object from like object of this class. Like if we write main and want to like final b is equal to b, so like this we can create object of base class. And so instantiated means we can create a object of this class. So this is it. So then this can be extended like inside library subclasses, but we can extend base class but only inside the library. I told you that library is this file and any file which is part of this file. So these things defined as a library. So we can inherit like extend this base class inside this file and any file which is part of this library. So and must be subclasses must be base, final or sealed. So it is like enforcing the restrictions. Like if we extend it with the normal class, then that normal class can be extended anywhere. Like the restriction will be like uplifted, like it won't be there. So the condition is we can extend a base class but within the library, and the base class must be either base or final or sealed class. Then we cannot extend it outside the library. So what is extend, inheritance, we will talk about it. And it can be implemented also. So when we inherit something, we have two ways to inherit, actually three ways, but for the class we have two ways. First we can use extend keyword, and then we can write like this: we are extending this class into this class. Or we can implement it, implements like this. So these are the two ways through which we can inherit some functionality of other class. So can be implemented also, it means that we can implement it with the implements keyword inside and outside library. So there is no restriction whether we can implement it inside or outside. So it is fine as long as subclass must be base, final or sealed. So when we implement or extend base class, the condition is extend only inside the library and implement inside or outside, but subclasses must be base, final or sealed. So this is it. So this is base class. We will see the examples, it will be like more clear. Then we have a final class. So whenever we add a final keyword, it means we cannot change something. Like we saw with the variables, whenever we add the final class, we cannot reassign the value. So same thing is with when we add final with the class, it becomes like cannot be extended or implemented outside of its library. So we cannot extend it or implement outside of this file, and means library, this file and any file which is part of this file. And when we extend or implement inside library also, then condition is subclasses must be base, final or sealed, so that the child class follows the same restriction, that we cannot implement or extend the child class outside the library also. So for that purpose we have this condition that subclasses must be either of these three types. Can be instantiated, it means that we can simply create an object of this class, and this is the condition with the final. Then we have abstract class. So abstract is like it cannot be directly instantiated, means we cannot create object of this class directly. Can be extended inside or outside of library, can be implemented inside or outside library, can have abstract method. So what is abstract methods? Let's say we have defined some function, let's say run, and we haven't told given the body. So this is a abstract function. And if we add another function walk and we define some body, so this is a concrete function. So this is an abstract function, this is a concrete function. So abstract class can have both type of methods, like it can have abstract as well as concrete methods. So abstract class is like a contract where we have some predefined functions or some function declarations only, like abstract functions, which can be implemented whenever we extend it or implement it. So this is the condition with the abstract class. So cannot be instantiated directly because we have some abstract functions. If we create object and call this method, it won't, like what it will execute, like it has no body. So someone has to provide the implementation of this function. So child classes can extend this or implement this and provide functional declaration of like body of this method. Then we can create object of child classes, cannot directly create object of this class. So that's why it cannot be instantiated directly. Can have abstract methods, it means that we can define methods without bodies. Can be implemented, like we can use implement keyword with this and extend keyword also. There is no restriction inside or outside a library, we can inherit it anywhere. So let's see, next example is interface class. So this will be little bit confusing, so please understand it very clearly. Interface class can be instantiated, it means like it is different from one we get in the Kotlin or Java. So that's why it is little bit confusing, because here interface, adding an interface modifier in front of class, because in Java and Kotlin we don't write class, we directly create interfaces, but here we have interface modifier that can be placed before the class. So this is a different, and it will have different behavior than the Java and Kotlin. So can be instantiated like a normal class, we can create object of this, because it cannot have abstract methods. Because if we write like void run like this, it will say hey give me a body, because cannot have abstract methods, because it can be instantiated. So that's why interface class cannot have abstract methods. There is a catch, if we add abstract method in front of an interface, then it will behave differently. So we will see that also. So here it can be implemented inside or outside library, cannot extend outside the same library. Like beyond this file we cannot extend it. Like if we add extend keyword here in this file, it will work, but in another file we cannot extend this class. We can implement it inside or outside. We can extend it inside the library but cannot extend outside the library. So that's the condition. So it can have concrete methods, like if we define walk, then give it a body, then it will work, because it can have concrete, cannot have abstract methods. So that's the case with the interface class. Then we have, if we combine these two things, like we have abstract class and we have interface class. If we combine these two things, it will become abstract interface class. So all the conditions that it has, it will be applied on it, this abstract interface, and all the conditions of this also will be applied on this. So cannot be instantiated because we have added the abstract, because we allowed it to have abstract methods, because abstract is like abstract class cannot be instantiated, so abstract interface also cannot be instantiated. Abstract class can have abstract methods, so it can also have abstract methods and can be implemented inside and outside library. So we can use it with the implements keyword. So but cannot extend outside the same library. So restrictions and the whatever functionality we have in the abstract and interface, they are combined in the abstract interface class. So this project will be uploaded on GitHub. I will here the class inheritance is the branch. You can directly check out and practice it, so that get better understanding of it. Then we have a sealed class. So there is like sealed class enforces the class hierarchy, where we must define all the subtypes inside the same library. So can be instantiated if not abstract. If we add abstract in front of this, so it won't be like cannot be instantiated, because the abstract keywords like conditions will be applied, but this class can be instantiated. Then can be extended only inside the library, cannot be extended outside, cannot be implemented anywhere. So we cannot implement it, like we cannot use it with the implements keyword. We can only extend within the same file or library. So this is the case with this. I use this class mostly with the like UI state or network state, like whether it is loading or error or none or success. So we will see example of that also. Then we have a special type mixin. So mixins are something that cannot be instantiated. We cannot create object of this, cannot extend it, cannot implement it. So it is simple, cannot do anything that a class can do, like we cannot create object of this, cannot implement it, cannot extend it. We can only use this thing with let's say here we added this and mixin G, so like this. Then any function, or let's say we define some method void run, then we can access this inside run method inside this, like void run, and run is also defined, so we can override it if we want to, and if we don't want to override, we can simply create another function and call run inside this. So this is the functionality with the mixins. We can reuse the functionality. So its concept is like reusing the code without like caring about hierarchy, inheritance, anything. So this is the mixin. And if we combine the class with mixin, then we can do anything, can create object, can extend inside outside, can implement inside outside, can be used with keyword. So all these modifiers can be combined with each other. There are certain restrictions that we cannot combine certain modifiers with certain modifiers. So all except mixin and abstract can be instantiated, because mixins cannot have constructor, so cannot create a object of it, and abstract cannot have constructor. So in this case also we cannot create object if they have public constructors. So all the other classes can be instantiated if they have public constructors, like base, and second line is abstract base sealed can still have methods with full implementation. Like we have seen, abstract class can have concrete as well as abstract methods, so can define methods with body. Base class also can have methods with the body. Sealed class can also have methods with the body. Then we have base, final and sealed are all about controlling subclassing rule. So whenever we add these keywords with the like class, then all the subclasses, all child classes must follow the rules that subclasses must be base, final or sealed. Then we have interface, and abstract can be used for defining contract. So if we use interface or abstract, we can implement it. We can use with the implements keyword, and whatever functions have been defined inside these two classes, that will be overridden and inside the child classes. So this is all about the classes, the different kind of modifiers that are in the Dart. So now we will see example of a normal class, how a normal class looks like. So we have seen a class, like if we write this one, this will be normal class. Let's see how we can make it private. So if we have, let's say, this class, so this can be created with this, like we can create object of this class like this. And what if we don't want to let anyone create object of this class outside of this file? Then we will define a constructor like with the underscore. So it will become a private constructor, nobody outside this file can call it. So whenever we have certain requirement that we want to make some class and we want to enforce that no one outside this file can call this and create object of this, so we can make it private. So this is a, because these are main method and this class is in the same file, so we are able to access this. If we add this inside some other file, so we won't be able to create object of this class. So we can import it, but it will say there isn't any constructor named underscore. So this is the case with the private constructors. Then what if we want to make full class private? So whenever we add underscore as a prefix in the class name, it becomes a private class, can be instantiated inside the same file only, like same library only. So in this file we can create this, but if we create this inside another file, it will show an error that isn't defined, the class isn't defined. So these are the two. Another thing how we can control the visibility of the classes. So we will see example of singleton class. So where this constructor is used, like whenever private constructor, like when we can use this private constructor. So whenever we want to make some class as a singleton class, so then we can use the private constructor. Like here we have a private constructor, that private named constructor actually. So it starts with the underscore, it means it is a private to the library. We cannot call this thing outside this library. And we have overridden default one. We have added a factory. So factory constructors can be used for different purpose, like we can cache some object, we can like here we have added a static variable instance that is also private, and we have called this class and this constructor. So we are creating a object of this class, and it will be initialized whenever we will use this, like we will read value from this, then only this class level static fields are initialized. So we have factory constructor. So no matter how many times we call this, it will return the same instance every time. So it will become a singleton. So it is a normal method, and this is a private constructor. So like if we have created two objects, but the value of both the object is same. Let's see the example. So it is saying true. So both these objects will be the same. So this is the example of singleton, how we can create singleton inside the Dart. So next we will we have seen the private constructors, we will see the sealed class. Okay, so we talked about the sealed class. We in like all the subclasses must be defined within the same file or library, and we cannot implement it, we can only use extend with it. So here we are creating a, like, let's forget about this for now, whatever this is. If we remove this and simply add something like this, so like this. So this is a normal class, it has a constructor, and we have created some factory helpers. So let's say we forget about this also. Now we have subclasses. So we have created a subclass of sealed UI state. One is error, another one is loading, another one is success. So error has a variable and a constructor to initialize this. Loading doesn't have any variables. Success also has a variable which is t type. For now we have removed the t type from the base class, parent class. So let's forget about this for now. Let's see the normal one first, then we will talk about the generics also. Then this is these are the three types of the UI state sealed class. So if we try to extend it outside this file, it will throw an error that it is we cannot extend outside the same library. So then we have defined some extension functions on this, we will talk about this also. So this is a normal class, these are the three types. Let's say let's see the t type, how we can, instead of fixing the data of a string, we can add it dynamic data type, like we can make it generic so that we can use it with any API call, whether it is returning a list or returning a user object or any model. So whenever we have added a t, that inside this class any variable can be of t type, and when we call this, we will define what is the type of t, like type of data that we will use with this class. So here error doesn't have any t type, simple is string. Here loading doesn't have any variable at all. In success state we can have different type of data model, like we can return list of records or a single user data model. So here we are using the t type. Then all the subclasses must also have the t type. So whatever t type is defined in the base class will be same in this class also. So here we don't have any variable with the t type. So in success we have a t type which is data. So this is the case with the generics. So it is little bit difficult to understand when you see this for the first time, but we will start practicing with it. in the upcoming Flutter examples we will get to know more about it. So it is a normal when function, extension function we can call when on this. Let's see how we can use it. So we have defined a state which has a type of UI state, and here T, like in this class there is a T. So what is the T? Here we are saying that our, in this case the T type is the string. So in the success case we can give it a string. If we want to give it a number, it will show an error because int cannot be assigned to the parameter type string because we have defined the T type string. And here we have success, we have T type is like this one, string. So we must give it a string. So we have created a success type UI state. So let's say if we want to match which type of state it is holding, so we have switch statement. We can pass a state inside the switch, then we can add a case that if it is a error state, go with this, if it is a loading state, go with this, and if it is a success state, run this statement. But in this case I think I haven't added any break statement, so probably will print all the statement. The last one, let's say we assign a error, all not good but all good. So it has printed error and error. Okay, so in the in the switch case, if we haven't, like we probably using the pattern matching expressions, that's why it is not going with the another like below this line. Otherwise in the Kotlin and Java, if we don't add any break statement, it will execute all the cases below this line. So in this case we have a error state assigned to the state variable, and we have a switch statement which checks for which type of state it is holding and running like respective statements. Then we have created our own function when. Then this is the pattern how we can use this. We can use this with the to return some value, also to return some widgets also. We will use this example in the Flutter when we will learn more about the Flutter. So this is the case with the standard switch. This is the case with the our own custom method when. So we have three callback functions, so it is accepting three functions, one for error, one for loading, one for success, and whatever thing is returning from here, the function will return the same value. So it is also a generic type. So we will learn more about the generics in upcoming sessions. So here we are saying that if it is error, return this message. If it is loading, return loading. If it is success, then return simply data, success and data. So this is the case. And there are other ways like we in this class, since we don't have any private constructors and private classes, so we have freedom to create error in two ways. Like either we can use the factory helpers like const factory, and we have defined name constructors and assigning the value object of this class. So here we have error. This is the first case how we can create object of error UI state, and this is the second case. So these are two same things. These are the two ways how we can create the UI state error, similarly of loading and of success. So another example where we have used private constructors, like in this case when we may have error class defined in many packages. So if we import error, it may show some other package, and by mistake we imported some package and it has some other parameters, so it will show some error. So instead of that, we can enforce private constructors. Like this is also a sealed class, so its constructor is private, like private base constructor, and we have same factory helpers, and all the subclasses are like private. When we create freezed classes, all the subclasses or implementation of the classes are private. Either they are private classes or private constructors, so we cannot call them directly. Like they are written like this with the has like this, like dollar symbol. So here we have private constructor, we are calling super constructor, and private classes. So how we will create object of this? This is the way how we can create a success state. If we call this, like we want to call directly with this, it show an error that it is not defined, because we have like this is the thing, but we are not going to use this thing inside the same where we have defined the seal class. We might be using it in the widget class or controller or repository, so we don't have access to the private classes, so this won't work in other classes. So this is the standard way with this. So we can create object of error, loading or success only with the factory helpers. So this is the thing that I will be using in the next classes when we implement the API and handle the data, state, loading, success, error, how we will implement this. We will see that in the next classes. After this class, I think we will be starting with the Flutter. So I think Dart basics is complete. There are a lot of things in the Dart also. There are a lot of things like there are like records, pattern matching, destructuring, but we will talk about them whenever we will use them. So we have seen the singleton, we have seen the sealed class. Another example of sealed class is like we have some shape class, and here we have defined two factory helpers with the named constructors. So we are like directly assigning the creating the object. So in this like we can create shape called shape dot square and pass some size. It will create a square shape, but its data type is shape. If we print this, it will return this, print this. So it has a same data type because base class is same, but child class are different. So we can create these things where we can have multiple things of the same type, like multiple things belonging to the same parent. Another thing is like let's see the mixing example because it is very simple. We have some car mixin with the name car run. It has some speed and it has a method. Let's say we have created a cheetah class where we have used the mixin class. Now we have, I think it doesn't have this function, so override won't work here. It is like unused expression. So here we have a method and we have another method run. So actually we are overriding this method and increasing the speed, then calling the super so that it can print this line. So let's run this so we will get better understanding. So this is the output. First it will like we have first called the make sound, so it printed this line. Then we have called this. So initially we had speed of 100, but instead of 100 it printed 200 here because we have assigned this. If we remove this, let's see, it will print 100. Where is main? This one. So see, it is running at 100. So this is a mixin, very simple. We can define some common functions we can use with any class without bothering with the inheritance or class hierarchy, base, final, anything. Then we have interface, then we have final classes, base class, abstract class. There are lot of things. So let's see the final class. It is a simple one. So can be instantiated as we talked about it, can be extended, implemented inside the library, and subclasses must be base, final or sealed. Cannot be extended or implemented outside the its library because it is a final. Cannot implement or extend outside this file. So let's for now we, whenever we will talk about the library, will refer to the file, because file, a library is more than a file. So for the simplicity we will stick to the file. So we have a final class API config where we have some assigned, we have a base URL and we are calling the constructor for the with the base URL, and we are initializing something inside this class. Let's say we have another subclass or where we are implementing API config. So we have HTTP API config. So when we whenever we create object of this, we must pass base URL. So we can write our own functionality here, but inside the same class, is inside the same file. Another, we have retrofit API config where we have extended it rather than implementing it, we have extended. So we are directly calling this constructor super.base URL. So we are passing here, so this will be configured. So this is a normal example of final classes where we have restricted the inheritance totally outside the file. Then we have base class example. So base class, like we have talked about it, like subclasses must be final, base or sealed. So this is a base class. We have draw method, then we have extended the base shape with the circle, and we have to make it final, sealed or base. So we have added a final keyword. We are overriding this, so we are printing, instead of drawing shape, we are drawing circle. Similarly, we have extended base shape with the polygon. We have created 3 shapes out of base shape, and we have like here we are, the parent class is base shape. Here we are creating a square out of polygon because it has edges. So we similarly we can make triangle, we can add properties related to edges, length, width, height, kind of things. So like if you want to create a fake shape, let's say we have defined some restrictions that only these types of shapes can be created, and we want to restrict the further subclasses, so we must define it with the base. What benefit it will give, that whenever we want to implement it outside this file, it will show error that it cannot implement this because it is a base class. Even if we are making it base, we cannot implement it. So all the things must be defined in the same class, same file. So this is example of base class. Then let's see the interface and abstract class. So let's see the abstract first. So it has abstract keyword. So we talked about that it can have abstract methods, it can have methods with the bodies also. So we cannot create object of this, but we can extend it, we can implement it. When we will implement it, we must override all the methods, provide it our own functionality. When we extend it, we don't need to actually override all the functions, only those are mandatory which functions don't have any body. So here we are overriding only necessary one, mandatory one. Here we are overriding both these because we are implementing it. When we use extend keyword, we are actually extending the methods and its implementation also. when we are implementing something, we are only extending or inheriting only declaration, not the body. So in this case, we have defined our own body, we don't need this body. So when we implement, we must define body ourselves. When we extend, we define bodies of whatever things are mandatory, like which don't have any body. And we can also override the sleep function, void sleep, and add a override on this. So if we want to define our own functionality and this functionality, so we can call super.sleep, so that we can have both this also and this also. So whenever we want to extend something, inherit the methods and the body, we use extend. When we want to inherit only the methods, so we can use implement. Similarly, we have shape class abstract. We have defined a constructor, factory helpers, and a method. We haven't defined how the shapes will be drawn. So whenever we will implement the shape, we will define how it will be drawn. So like this. So we can create shapes, we can print. Another example of abstract class is we have a payment processor, and we can have multiple payment gateway, like we have Stripe processor, we have PayPal, we can add Paytm money, phone pay, all the payment providers, and all the payment provider must implement this thing. When we are extending payment processor, so we are providing the body how we will process the payment, because payment processing is responsibility of the payment gateway. It will return a success or failure, like it is returning void. Instead of this, we can have a state. So we will say that whenever you are done with the payment, let me know what is the status of the payment. So here, instead of the arrow function, we will convert it to the body and add a return statement. So for now, let's keep our previous thing. So this is how we can create a abstract class. So final one is interface class. Interface. So we have seen abstract. So abstract, we have two types of restrictions of interface also and abstract also. So interfaces, we talked about it, you can read about it already. Video is very long, so let's quickly cover it. We have a interface camera driver. So depending on the device, we can have either Android camera driver or iOS camera driver. So we have defined how the take photo function and the connect functionality. So take photo is like abstract, and connect has a body, method body. So when we implement it or extend it, we must, when we implement it, we must override both these methods. When we extend it, we can override only mandatory one, which don't have any body. So here we have these things. Android will be responsible, like Android camera driver will be responsible for taking photo, and we can also add a return statement here so that we can get the photo. So this is the common, like, get better understanding how where these things can be used. Abstract interface also can be used where we define the repository and repository implementation in the MVVM architecture. So there it is mostly used, and these are the things where also used, like depending on the platform or different type of payment provider or different types of shapes. If we see the widgets, let's see this one. Here it is a abstract class. It doesn't have any like it doesn't have the body of build method. Someone else is providing the body. So it is an abstract class. So whenever we extend it or implement it, we must override this thing. So stateless, here we are extending stateless widget, so we are providing the build method. So what will be shown on the screen? We are responsible for providing its content. So this is where abstract is used. So this is the thing. Then we can go inside the widget also. It is also the abstract. So here it is a final. So most of the things that we have read so far has been used. It is a static widely in the Flutter framework itself. So it is extending widget, creating abstract class to make it stateless or stateful. It has a constructor with the named parameters. It has a arrow method, create element, so that it creates an element of this, and stateless element. This is extending another class. So whenever it will create, it will call the widgets build method, and we have update. So all the things you can go in the Flutter code and see how these things are implemented. So I think the Dart basics is complete now. There are a lot of things that we haven't covered, but we will cover them whenever we will come across any new type. Like we will talk about the records, we will talk about the pattern matching, destructuring also, and there are a lot of things. So for now, in this with this class, we have covered the Dart basics, the necessary one, and in the next class we will start with the Flutter. So we will first see the project structure, then we will create a project from scratch. We will see how the project is created, and we will start talking about main and everything in whatever provided by default. So stay tuned. Thanks for watching.